Hi everyone, I am Avdesh God. Congratulations on making it to section 6. You have made quite some progress so far. In this section, we will be mastering the calculations in Tableau. We will get started with a basic understanding on calculations. How to quickly create a new calculated field. We will also understand the in-shelf calculations in Tableau. We will be exploring the different type of functions in Tableau, that is, the built-in functions. We will be exploring in detail some of the most utilized categories, such as the string calculations, numeric calculations, the type calculations, logic, and date calculations as well. Thereafter, we will understand what table calculations are and how to use them in Tableau. Finally, we will understand in detail what level of detail expressions are, why are these required, and when to use the same in Tableau. We will cover the fixed, include, and exclude LODs with appropriate use cases. We will also understand the difference between these three as we move along. And in this video, we will kickstart with the understanding of built-in functions. Well, let's get started. Calculated fields in Tableau are created using the built-in functions. These functions are used to define the required logic based on which our calculation is built. Suppose we want to define whether a subcategory is a profit-making or a loss-making subcategory. To implement the same, we can write down a quick calculation in Tableau. To do so, click on the drop-down available in the top right of the data pane and select Create Calculated Field. To implement our requirement, we can use the if-else logical statement. That is, if the sum of profits is greater than equal to 0, then mark it as a profit, otherwise mark it as a loss. We will end this statement with an end expression. At the bottom, Tableau has verified that our calculation is valid and is ready to be used. If in case we are not so sure about what will be the correct syntax of the logical if-else statement, then we can easily verify that. Over to your right hand side, we have got a drop-down. Select logical out of it and then select the if statement. Tableau will provide us with the further details on the if operator over to the right hand side. This will also provide us the correct syntax for a quick reference. Moreover, we can see an example as well for our further clarification over here. If you notice, a function is represented by a blue color in the calculation pane, and that's why If you notice, sum is coming up in blue color. If in case you are curious about what operation does a function perform, then all you need to do is click on the same. Let us click on sum, and over to your right, Tableau will provide a quick explanation over the same. That is, over here in this case, Tableau mentions that the sum function returns the sum of all of the values in the expression. Moreover, it also mentions that the sum function can only be used with numeric fields, and null values are ignored by this function. Let us name this field as profit or loss. In order to save this calculation, let us hit OK. As soon as we do that, a new field will appear in the data pane with the equal to icon in front of the data type of that field. This equal to icon identifies that this is a calculated field. Let us create a quick view to use this field into the view. Let us put up the subcategories present under the product hierarchy onto the row shelf. Let us drop this new field, that is profit or loss, onto the text shelf in the marks card. Over here, we can easily identify which subcategory is a profit making and which one is a loss making. We can easily see that the subcategory bookcases, supplies, and tables are a loss making subcategory, whereas the other ones falls under the profit making ones. Now suppose we want to bring the category and subcategory as a single field. We can easily build a calculation for the same as well. But this time, let us write this calculation directly over the shelves card. To do so, let us double click over to the row shelf. Tableau will provide us an option to write our calculation. In order to concatenate two fields, Tableau uses the plus operator. Let us type the category field first, and then a plus sign for the concatenation. Let us separate the category and subcategory with a dash in between. We will enclose the dash along with some spaces in the quotes so that it can be used as a string. Thereafter, we will put up another plus sign followed by subcategory. Over here, in this expression, we have three strings. One is the category field, the other one is space dash space enclosed in the quotes, and finally the subcategory field. Along with these three strings, we have two plus operator to concatenate these three strings into a single one. Let us hit enter to confirm this. As we can see in the view, Tableau has created a calculated field wherein the category and subcategory is separated by a space, dash, and a space. This is how we can write calculations directly over the shelves. We can also do the same with any other shelf as well. May it be the column shelf, the color, the size, text, or any other one as well. Moreover, if you want to save any of the shelf calculation, we can do that as well. To do so, let us drag our shelf calculation to the data pane. Tableau will also provide an option to rename this. Let us keep it as it is. Now we can use this anytime we want as a regular field. If in case you wish to modify a calculated field, right-click on it and select Edit. Let us change the separator between category and subcategory field from a dash to a colon. Once we hit apply, we can see the changes in the view as well. Let us hit OK and close this calculation. Now suppose we want to find the length of a string. We can easily find the same using the length function, which is abbreviated as len in Tableau. Let us quickly create a calculation for the same. We will type the length function with a start bracket followed by the field whose length we want to find, and then we will close the parenthesis. If you want to see the further details, you can click on the length function and the details will appear on the right hand side. As we can see that the length function expects a single argument, which is string in nature. Moreover, we also get to know that the return type of the length function is numeric in nature. Let us save this by hitting OK. Let us bring the length calculation to the text shelf by replacing the existing calculation. As of now, it seems a bit weird. The length of art is 3, but over here we can see it as 2388. Reason being, Tableau is aggregating the length of art for all of the fields that are having subcategory as art. To rectify this anomaly, let us change the aggregation to average instead. In this way, by averaging out We can remove the multiplier which comes in case of sum. This now shows the length of the values present in the subcategory field. Let us now discuss some other string functions. What if we want to convert the string in either uppercase or lowercase? This can easily be done with the help of upper and lower function respectively. Let us create a calculated field for the same. To convert any string in the uppercase, we will enclose it in the upper function. To get to know more about the upper function, we'll click on it. We can clearly see that the upper function expects string as an argument, whereas the returned value by the upper function is also a string. Let us save it by hitting OK. Let us now quickly create a calculated field for the lower function as well. In the similar fashion, to convert any string in the lower case, we can utilize the lower function. To get to know more about it, click on the same. The lower function also expects a string and results in a string as well, which is all letters in the lower case. Let us quickly save this and bring these two strings out there onto the row shelf. We can clearly see that what operations these functions have provided on the string subcategory. Now suppose I have a requirement where I require only the left two characters or the right two characters of a string. We can easily do that using the left and right functions respectively. Let us quickly build the calculations for the same as well. If you notice, as soon as we write a function, Tableau provides us an assistance in the hover over. If we see the very first argument that the left function expects is a string, while the second one is a numeric character. We will get to know more about once we'll get the details over to the right. But before that, let us complete the calculation first. The first argument to the left function is the string based on which we want the specified number of characters from the start. And then we specify how many number of characters we want to extract from the start of that string. Let us hit OK to save this and create another one using the right function. In the similar manner, right function also expect two arguments. The very first one is the string based on which we want to extract the number of characters from the right, and thereafter, separated by a comma, we specify how many characters we want to extract. The output of the write function is again a string. Let us hit OK to save this field. Let us quickly bring these two fields onto the row shelf. The operations of these two functions are self-explanatory. What if we want a column to be separated into two different ones based on the separator field that we have in that column? We can easily use the split function to perform this. Let us quickly create a calculation for the same. If we do not know which function falls under which category, we can use this search option available on the right hand side. As soon as we type a function, it comes up in the search box. Over to our right, we can easily see that the split expects a string, a delimiter, and a token number. The functioning of the split function becomes much more clear once we look at the example. The very first argument is the string that we want to split. The second argument is the delimiter based on which we want to split that string. And the third one is the token number that specifies what portion of string do we want based on the delimiter. Let us quickly write this calculation for the combined category and subcategory field that we created earlier. In our case, the token is the colon. In our case, the delimiter is space colon space, and if we require the category portion of it, we can write the token number as 1, whereas if we want the subcategory field to be extracted, we can write up the token as 2. Let us save this and hit OK. Let us quickly bring this to the row shelf. Right now, as we have specified the token to be 1, the split function is providing us the very first portion based on the token of the string that we have passed to this function. Let us change the token by editing the field to 2. Once we hit apply, the changes are visible in the view. Now it is providing us the second substring that it has splitted based on the token. We can also provide the numbering of this token from the right hand side. To do so, all we need to do is use a negative sign in front of the token. Now from the right hand side, category is having the token as -2, whereas the subcategory is having the token -1. Let us hit apply and the changes are visible. If we change it to -1, we can again see the split function providing us the subcategory. Before wrapping up, let us discuss the last function, that is contains. This function is quite useful when we want to find whether a string contains a particular phrase or not. Let us quickly create a calculated field for the same. The contains function expects two arguments. The very first one is a string in which we want to check whether a particular phrase is present or not, whereas the second argument is a substring that we want to check whether it is present in the string or not. If the substring is present in the string, then the value returned by contains is true, otherwise false. So in a nutshell, contains return a Boolean expression. Let us hit OK and save this. Thereafter, we'll bring the same in the view. We can clearly see that accessories is having ES, whereas appliances is having the same as well. So the phones, supplies and tables. That's why the value is true over here. Whereas in case of labels, we do not have a ES phrase as a single one in the string. In the next video, we will continue exploring the string and numeric built-in functions in Tableau.